Willkommen, meine Damen und Herren. Bienvenue, Monsieur, Mesdames. Welcome, everybody, wherever you are in the world. This is going to be exciting. We're going to be discussing Volkswagen's Power Day. Now, who's Volkswagen? Well, as I see it, when I was watching it, it felt like one of those change moments where the manufacturer, formerly identifying as Volkswagen, now wishes to be known as Volkswagen. So that's definitely what we're going to unpack. What did that actually mean? And I've got in my hand a Rubik's Cube. It seems to me that what we heard yesterday from Herr Diess and his team was the really movement of like a Rubik's Cube for automotive, where we are with a whole host of challenges in the supply chain, in manufacture, in the employment aspect, in the strategic sense of where is the world going with many of these things. So we heard from all of those component parts, a bit like a Rubik's Cube, trying to connect them all up, trying to get them all the same side, the right color all the way around. So we're going to be talking about what we heard. We're going to be unpacking the battery proposition in particular. And of course, supply chain, gigafactory, that's really the meat and potatoes of what Benchmark Mineral Intelligence is all about. I've been learning this last couple of years all about chemistry. Well, to some extent, I wouldn't say all about, a little bit, and supply chain and what that means to batteries, and of course, the EV proposition overall. So we'll be talking about that. And we'll also be really going into questions and answers for about 20 minutes near the end. So about 2/3 is our presentation. 1/3 will definitely be questions. So if you've got them, please put them up. We'll do our best to answer as many as we can. So without any further ado, I would like to welcome the head honcho of Benchmark Mineral Intelligence. I haven't called him that before, but he's worthy of that title because this is quite an army of analysts. So Mr. Simon Moores, good morning. And thank you for inviting me to host this very exciting event. I watched the whole 2 hours myself live, and I watched the replay. That's because, you know, the electric vehicle world for me is fascinating and interesting. So, Simon, please kick it off. What was your first impression? What's your key takeaway, if you like?
Car companies talking about batteries in detail. You know, this is something that we've been waiting for a long, long time here at Benchmark. You know, something I never thought back in 2006 when I started looking, and this as part of my career would be a thing. In this level of detail. So my takeaway quite simply was, or is, a car company saying to the industry, you know, one of the world's biggest car companies saying to the industry, we're going to take it into our own hands. We're going to take control of at least the downstream of the battery supply chain. We're going to make our own batteries, but we're going to be open to joint ventures. You can come along on our journey if you want to, if you can match the quality, but very much this is not VW or the auto industry anymore relying on the battery industry to lead the path. It's the car companies taking control.
Right. Okay. Thank you. So let's just go for the other chaps that we've got. Caspar, can I ask you, did this sound familiar at all? Was there any sense of deja vu? Have you heard another vehicle manufacturer in the world talk about building the ecosystem, vertical integration, ensuring that you can feed your battery with mineral stock? Did any of that sound familiar, just out of interest?
Yeah, I mean, yeah, there are similarities between this and another large US EV manufacturer. But, you know, I think really the takeaway for me is that VW are taking vertical integration seriously, which is something that, you know, we've said is going to be a really key step for automakers going forward. And, you know, it wasn't quite as wide ranging as the other announcement, but it was pretty much there. And also, I think, you know, some very realistic targets were in there as well, which was interesting. So yeah, it's a major shift in kind of the attitude of the automakers towards the industry. I think, you know, it's really important, and it does leave questions open to, will we see, you know, this spread even more quickly throughout the industry?
Yeah, I mean, it certainly is complex. And what struck me was, whilst it was fantastic to see, you know, a grand plan emerging and the details, or some of the details around how that would happen. Some of it was predicated on things that are still work in progress. You know, they mentioned, for example, solid state batteries. I know we'll come on to that. So I'm really keen to sort of get a flavor from you, and I'm sure the audience is, around, you know, how robust is this? How much of this is really credible and can happen within the time frame they've suggested. And Rob, I'd like to come to you next for your key takeaway, but can I just explain? I'm standing up rather than my normal sitting down because I felt I needed to give the thing proper attention. And yeah, it's a significant moment. And if you'd asked me when I kind of joined the EV kind of ambition back in 2007, did I ever think we'd see a huge company like Volkswagen, especially what happened a few years ago from them? Let's not forget that. Would I see this moment emerge? No, I wouldn't. So I do feel genuinely very energized by it all. So what about you, Rob? What was your kind of sense, your flavor, your key takeaway, if there was one?
Yeah, it's almost like auto's incumbents are crossing that Rubicon. Tesla's a challenger. It's not established in that. It's coming in and mixing it up. Whereas Volkswagen came in, put their flag in the sand in Europe. They're ambitious goals, but they're, like Caspar said, they're realistic, their cell plans. It was very much downstream focused. If you compare it to Tesla's battery day, they didn't go to too much on the raw materials. And then lots of interesting takeaways from it. Interesting stuff on the cell chemistries and anode materials. So there's lots to talk about. That's sort of my
there definitely is. So I tell you what, why don't we kick off with the big one that sort of stood out to me, certainly, was 6 gigafactories. So who wants to have a stab at that? What is your take? What is your sense of how will that work? Can they really get to this point where you've got, you know, 2005, 2006, another one, 2007, another one, 2008, another one? Building gigafactories, we've already seen, can be done, certainly, but it's a big challenge in many aspects. So let's start with building 6 gigafactories in Europe. Anyone want to pitch into that? What's your flavor of that ambition?
I know Caspar's going to jump straight into the numbers, because Caspar collects these numbers on a daily, weekly, monthly basis with his team. So before he jumps in straight to the numbers, Mr. Big Data, we call him, just my higher level sort of thinking on this, like we've been adding these battery gigafactories or megafactories to a proper methodology to our systems and our models since 2014. And it's a process we formalized in 2017. And adding 6, okay, it's in a time frame of 10 years, which is actually the bulk of the work we do anyway. But to add 6 in one hit is China levels of pace, if you like, China levels of speed, of capacity. So that's the first thing. You know, Europe is building individual gigafactories, battery megafactories, and reasonably significant capacity. 40 gigawatt hours per individual battery plant it's as big as the biggest plant in the world, which is the Tesla gigafactory at present. But it's not going to be anywhere near enough. We can discuss that as well. And the other thing is what I've been saying to the Senate before in the US government is this kind of phrase. So the way this rate of building out capacity, the way I like people to think about it is, well, China, we're adding 1 gigafactory every week to our China numbers, but we're adding 1 every 4 months to our US numbers. So, and Europe is really somewhere closer to was before VW, closer to US rates than China rates, but now it's just jumped up. So that's kind of the rate of this growth over the next 10 years, but Caspar's probably going to jump in with massive numbers, right?
Just before you do, Caspar, for anyone watching that's not familiar, so welcome back to our regular visitors, and you're warmly welcome if you're a first timer. What Simon alluded to there was the 3 times he's presented to the US Senate Energy Committee, and Lisa Murkowski, I think, invited him to the first one, and that's where I got to know this bloke and what the company does with the phrase, we are in the midst of a global battery arms race of which the United States is a bystander. And that was like the opening words to a movie, as far as I was concerned. It really set the scene of, China has taken the lead, not in secret, nothing sinister. It's done it in front of everybody, but we really need to massively play catch up if we want to go on this new energy ambition, new energy being renewables and of course, electric mobility. So sorry about that, Caspar. I just wanted to jump in because I know he's shy. He wouldn't tell everybody what that was all about, going to the White House and all these things. But I'm going to tell people because it impresses me. Caspar, 6 gigafactories. How's that going to happen?
It's going to be a challenge. I mean, I think it's achievable. I think the key thing is to remember as well is 2 of those plants are effectively already in construction. So it's not like we're going from a standing start to 6 in effectively 9 years. I think though, if you look at the numbers, so they effectively say that from 2025, the first plant in Germany will be in production. 2026 is Western Europe, 2027 is Eastern Europe, and then you've got 2 more by 2030. So they're going to be adding a plant every year for 5 years, effectively. I think, we shouldn't understate the challenge of doing all of that and getting those batteries into production. But it is achievable. I'm not saying it's not achievable. I just think it's going to be hard. One thing that would be interesting to kind of get a feel for is how many of those plants will be joint ventures, like the plant in Sweden with Northvolt, which is effectively what they're using as a joint venture now. And the plant in Germany will be, sounds like it's going to be VW operated. So what's the split between joint venture plants and, should we say, VW's battery arm? So, I mean, but it's roughly needed. I mean, it depends what, if you translate VW's market share into the electric vehicle market, it's not an unreasonable figure. It's on the high side for the year for the year 2030, but obviously they're looking to supply beyond 2030. So when you take that into account, it's not unreasonable. And at the moment, Europe continues to surprise to the upside in terms of demand. So, even by 2030, maybe we see there's further commitments. But I think we had prior to this in the region of 550 gigawatt hours of capacity in Europe by 2030. Sounds like a high number, but in reality, I think it's not ridiculous. And, I think the challenge will be, obviously, as it is for every company on Earth, is being able to manufacture the quality of batteries needed at that scale. There's pilot scale battery production, which is challenging, but it becomes a whole different ball game when you're trying to go to 10, 20, 30 gigawatt hours.
And I think also practicalities for me, the principle is great, the plan is cool, but the practicalities of doing it, for example, with people, where is the skilled labor force? Where are the people with the training? I know I went to the Battery Innovation Centre, the BIC, or Industrialization Centre in the UK last year, when we were allowed to go out anywhere. And the thing that struck me about that facility was a lot of that is about training people, it's about developing skills, it's about people understanding the process of manufacture of anode and cathode and pack assembly, etc. So I'm sure that what we'll equally see, well, I hope we will, is the ability around Europe to skill up the labor force. And I think in that regard, this transition to electric vehicles, the managed transition that we all want to see, could mean that a lot of people who sadly are going to lose their jobs in engine plants and other places, where at all possible, potentially can transfer their capability and skill up to go and work in these facilities. Because you can't just sort of click your fingers and build a bunch of battery factories. You've got to have clever people inside them and people who know what they're doing. So yeah, it's a fascinating time. What about chemistry then? Because we heard some interesting things there about LFP. We heard a lot in there, which you guys know a lot better than I do, in terms of where we are with different battery chemistries for different applications. And of course, they talked about solid state. That was inevitable, and their partnership with QuantumScape. But I'm trying to reconcile where this all means, because yes, there are the numbers, but where do they all add up? Can you kind of help me get a flavor of what you heard the other day in terms of how realistic is this when you've got work in progress with different aspects of chemistry choice for batteries? Is that really a question, or am I making a statement? I'm not sure, but yeah, talk to us a bit about the chemistry that we heard.
Yeah, I think chemistry can, links into sort of battery types. So chemistry is a battery, right? Is a battery type, and I think from a higher level, what was really interesting is two things. One is the LFP moment, if you like, for VW. For the lower end cars, or let's say the shorter range, lower price cars, it's clear they want to go down an LFP route. Then, of course, you have our classic NCM chemistries in the middle, which are for your say Model 3 level vehicles that go 300 plus miles. And the key thing there for me was obviously high manganese. So that's a new thing. It's a BASF are usually the ones talking about high manganese, and of course VW now wanted to do that. And then of course on the high end you've got the future, if you like, solid state batteries. So the way I view chemistry and battery strategy is in those three buckets, and the question is what proportion of their vehicles will fall into each bucket, and then that will also then feed into what their average sell price cost is, which we'll talk about later on, right? But chemistry is batteries, and I think for me that holistic VW strategy showed firstly that it's a complete that not one battery type is winning the day. This EV growth, this EV electrification movement is just a huge pie that keeps on growing, and every battery will find their niche for whatever strategy or whatever application that's needed. So that's kind of my initial take on the chemistry side. But I don't know if Rob has got any comments on that. But yeah, that's my take.
Before I talk about chemistry, I was looking at some numbers. And you mentioned Europe catching up with China, so talking at cell production. So China's obviously got hundreds of mega factories in the pipeline now. VW's announcement would take the mega factories in the pipeline in Europe. These haven't been added to our assessments, and I'm sure Caspar and his team will look at that. That takes it up to around 22 mega factories in the pipeline with around 750 gigawatt hours capacity. So I looked at China a couple of years ago. So at the start of 2019, China had a terawatt hour of capacity in the pipeline. So Europe's catching up, but it's at least 2 years, more than 2 years behind China. But Volkswagen's announcement show the trajectory there. Chemistry, yes. So Volkswagen suggested, I think, that around 20% of their cells will use NCM chemistries, and then the unified cell will be using.
Yeah, what is that? What can you explain? I know a little now about a lot, which is very dangerous. You guys are the experts. What the heck is a unified cell? What does that mean?
Yeah, so from the presentation, I mean, it looks like it was a prismatic cell, and it would be the same dimensions, the same cell for every model. So they'll have a slightly different chemistry within that shape, the format we say, but it's a change for them because, in Europe, the majority of their supply comes from pouch cell specialists. So this is a shift in kind of the tech in the format, which brings about some challenges. It will be a slightly different, obviously, production process. They mentioned that they would use a folding and stacking process in their, normally a battery's made, we call it the winding step, where they wind the anode and cathode on the foils, literally wind it up. But they talked about stacking in their presentation. So there are some technology changes in the production that they're obviously targeting. But yeah, it's essentially, it's not, prismatic's not a new format, it's nothing new, but it's new. It's a new commitment to Volkswagen to use that across 80% of their vehicles.
And the winding is for those the cylindrical 18650, and the stacking and cutting would be for the square ones. It's quite a simple thing. But I think also the other thing we'll talk about is the dry electrode chemistry. There's hidden manufacturing tweaks in there that maybe people didn't pick out, and that also is a contributor to reducing this cost of a battery cell level, which they talked about.
Right. Well, the picture you're painting to me is I'm imagining a tightrope walker juggling at the same time. This is what the next few years are going to be. Well, let's be honest, for the industry, not just Volkswagen. So can you just give me a little 101 on something? So we've got prismatic, pouch, and cylindrical. The acknowledged leader of battery capability in the world for certainly automotive is Tesla, and they use cylindrical. Why didn't we see something about that yesterday? What is that choice of what's the rationale around that choice, do you think, in what you heard yesterday, compared and contrasted to Tesla? I don't want to do everything in comparison to Tesla, but I do think it's relevant in the context of where we all are.
Yeah. So there's a couple of reasons I would say. Primarily, I think Tesla initially chose that cell format because that was what was available at the time, all those years ago. That was the consumer electronic format that they could get their hands on. So that kind of drove their selection to some extent. I think another factor that's kind of played into it is that if you use, obviously cylindrical cells are much smaller, or typically have been much smaller with the 18650 and 21700 than a prismatic. You would have a lot more cells to manage in your pack. So you would have thousands rather than hundreds of cells, which can bring around challenges in terms of pack management and software, which is something that the majority of automakers didn't have experience in when they started this. The vehicles that are coming out now, I'd say, are like generation 1 of the true EVs that have been designed by legacy automakers. So at the time when they started designing these vehicles, which was back in kind of 2017, something like that, 2016, 17, 18, it was a whole new thing for them. But the next generation will be something different again. So in the mid 2020s, when the new platforms start being launched, they will have this experience and knowledge that they gathered over 5-10 years, which may see some deviation in terms of format. But I'll just add final point before I hand over. VW they didn't actually say it, but in their 20%, I think they called them speciality or special purpose cells or something like that, there was an icon that was a cylindrical format. So maybe they will use that. Maybe that will be in kind of higher end performance vehicles, perhaps, or something. We'll see, or higher cost vehicles. But it doesn't mean they're not going to use it at all. But I think obviously the bulk, 80%, is going to be this unified format.
And on that point, there were 2 points actually. One, that speciality cells, that the plant they've just bought Northvolt out of, which they then rewarded Northvolt with that 14 billion contract, is going to be for these speciality cells, right? Unless I read that wrong. And then, is that right, Caspar? Right. I
think some of it will. I think the majority of it will probably be NCM, but in prismatic format. But I think there is potentially cylindrical.
So the question there also is, it's my understanding, because of the timeframes, that plant's coming out in 2023, is aiming for at the moment or something. So is that right?
Production there starts at the end of this year, or is scheduled to start at the end of this year, but it will be the reduced capacity. I think the 2023 date is referring to when 40 gigawatt hours should be online for Volkswagen.
Yeah, so which will take longer than that.
Yeah. Quite possibly. But, first production from Northvolt's plant more generally is later this year / early next year.
Yeah. So actually this number one is how, if they've installed the technology already, which is kind of Northvolt technology, how do you then make high-end batteries there? It's obviously they're going to maybe build in solid state lines in addition on that site potentially. The next point is, and it goes back to the numbers Rob said, so I'm going to get Rob to repeat the numbers because they're really important for people to write down, is how long it takes to build these gigafactories. What's the time frame? So we have these numbers because we've done some detailed work on this the last 4 months. So these are for 10 plus gigawatt hour plants. So the gigafactories of today and tomorrow. At the moment, from breaking ground to actually starting the plant, turning the key, if you like, this takes on average 2 years and 7 months. Could be 2.5 years to 3 years. Could be 2 years if they're super quick. Then from turning the key to having, let's say, a industry standard, which is reasonably good, utilization capacity, i.e. getting those quality cells into the market, not the cells that are wasted, not the scrap that comes off the line, but the cells that car companies can buy, takes on average much longer than building the thing. 3 years and 9 months on average for the 2 North America plants. So my point is that these things at multi-gigawatt hour scale, tens of gigawatt hours, take the best part of 5 years to build and get up to a certain quality and quantity for the automakers to use in EVs. Not easy. And those timelines aren't going to change drastically anytime in the next decade.
Well, that's really fascinating, because if you try and reconcile this, a bit like my idea of having a Rubik's Cube, with the cessation of manufacture of internal combustion engine in 2030 or sooner in some countries, you kind of think, well, that's all well and good, but we can only do the switch, if you want to call it that, when we've got the capability to deliver it. You can't switch off one thing without being ready to switch on the other thing. So what fascinates me is in what you just explained, which I've heard variations of before from different people in the industry, is, how ready are we? And it's not a question of trying to push back the date. It's not a question of going soft on the switch. It's not a question of saying we don't want electrification. We do, but we have to have a successful transition. So the intriguing thing in all of what you've just said and what we heard yesterday is, yeah, great, but can you really do it? And can you really do it also, of course, comes back to some fundamentals like profitability. How much does this all cost? So cell costs, what did you learn or hear yesterday, either that you knew already and it reconciled your thinking, or you heard that was new? Where are we with cell costs? Because as supply chain gets stretched and as the demand goes up and the ratio of supply and demand dictating price is always there, where are we with cell cost and pricing then at the moment? Can any of you give us a flavor on that?
Yeah, I mean, Rob, I don't know if you want to jump in on this from a high level and I go into detail, or?
I don't have the numbers to hand. Obviously,
I caught you out.
By the way, how am I sounding? I understand my mic is a bit quiet. Better now?
Yeah, just shout like I do, Rob, and it'll be fine.
That's exactly. I think the neighbours can hear me at the moment. But I mean, we put out a couple of articles recently on membership just about cell price falls, cell costs going down in general, and the years of double-digit declines, just they're not there anymore. So Volkswagen's going to have to work very hard looking at different chemistries to achieve this. I think you've probably got more detailed numbers, Simon, you were saying, so I'll let you go into
Yeah, I worked on some. I looked at obviously last year was, well, let's say, our average, which is automotive large contract average for NCM lithium ion battery cell, was $110 a kilowatt hour at a cell level for the contract price, right? So, and that's come down from 280 in 2014, really the first year people cared about lithium ion batteries in a big way. Actually, people haven't cared since 2017. So that's a significant drop. But then if you actually look, the most recent years, as Rob was saying, though, that drop, the rate of decline has halved. So it's gone like flattened. Now it's still around 7% decline in the last 2-3 years. But the reason that decline has flattened, that line has flattened, is because the proportion of raw materials are a much bigger portion of the pie now. If you go from $280 a kilowatt hour 4 or 5 years ago, you're looking at 50% of the cell cost is your inputs, your raw materials. Now you're looking at upwards of 80%, especially if lithium price is going up. In China, carbonate's gone up 100% since January 1st, which isn't good for LFP batteries, by the way. Nickel's gone up and it's come down a little bit recently. Cobalt spiked along with lithium. This isn't a positive time for people making battery cells and wanting to continually drop costs. This is a time of, it's the oh crap moment if you haven't got those prices locked into contracts. But everyone's talking about massively ramping capacity. So what they're doing eventually is undermining their raw material position if they haven't got these contracts locked up. But you know what, and this is what I said on Twitter. I said, you know what, at the moment, Tesla is battery day, VW is power day. In about 18 months, that will be mining day and chemical day at these companies.
Yeah. Simon, an oh crap moment, I get it, and I think everyone will. It's not as eloquent though as global battery arms race, but we'll take it. We'll take it. So what about getting into chemistry a bit. So they mentioned, for example, silicon-based anodes and moving away from graphite or synthetic, moving to synthetic graphite. How credible is all of that? Again, within this really tight time frame they've set themselves. Amongst other things, there are other chemistry things which you all understand far better than I do. So what about the takeaway from the chemistry proposition that they were sharing with us?
Sure. So from the anode aspect, they suggested they'd be using synthetic graphite and then eventually silicon additives. They didn't go so far as Tesla to suggest pure silicon anodes, which isn't a commercially viable or even achieved sort of anode material at the moment. Just to give a bit of context, there's a fairly balanced split in use between synthetic graphite anodes and natural graphite anodes. At the moment, I'm just looking at the numbers. Last year, around 58% of the market, anode market, was synthetic, and then 40% natural anode. By 2030, you'll almost see that shift, with synthetic around 40%, natural around 50%.
All right, so sort of going the other way then. That's intriguing.
Yeah, so there's a few reasons behind that. Natural is a lower cost input. Synthetic's higher cost, but there can be some supply chain issues. And really the trend is that automakers use a blend. So they don't not everyone is typically using just one anode material. There's a blend of natural and synthetic. And then silicon, with regards to silicon, I think around, in some cases, 3 to 6% of silicon is used as an additive. So at the moment, the market share of silicon as an anode material, looking at benchmarks forecasts, I think it's less than 1% last year. By 2030, we're forecasting that to increase to around 6-7%. So still a very small proportion of the supply chain.
That's really right. That's a really important point as well that Rob raised up. You can't be you're aiming to significantly drop your cell costs, and VW said they wanted to get to 100 euros at a system level, not a pack level, but let's call it a system level, because probably packs are going to be eliminated in some way, which translates in my numbers to about 80 euros at a cell level or $95 at a cell level. So that's their target. Now, you can't be, aggressively going to that target and using pure synthetic graphite. It's too expensive. So you need to blend that with, let's say, the natural anode graphite, which is much, much cheaper. And the key thing as well is, as Rob was mentioning, is that consistency for the anode material. At the moment, it's a very inconsistent product, especially if it's natural anode. It's coming from lots of different flake graphite mines from around China. The majority is from China. You've also got Syra resources as well in Mozambique. And then that gets made into an anode powder, spherical graphite that's coated, and then it goes to the battery plant. And because it's so inconsistent at the moment, they blend it with that natural so they can control those levels before it then goes into the solvent mixes, right? So it's too expensive, and I don't see, absolutely, if you need the volume and you need that cost to drop, you need the proportion of natural graphite to increase. But both are going to be critical. So you have to fully understand these really niche supply chains to actually drop your cell costs significantly. Right.
This all sounds like a challenge and a problem, and we've got one as well right here and now. So it's 20 to the hour. I don't think, can we extend by about 15 to 20 minutes or something, Simon?
Yes, the demand is high. We carry on, right?
Well, I know there are 30 questions there. So, at some point soon, we're going to have to start going through these, but and I'd really want to, because that's the promise we always give. And you've got to keep your promises. So let's just talk, because some of the questions in here are about raw material supply chain, which forensically. So where does this all reconcile now with, and all of you have alluded to it a few times in here, with regard to partnerships, joint ventures, even acquisitions, up into the mining and mineral processing arena. What might we see as a consequence of this? I saw Volkswagen's share price went up. So, the market liked what they were saying. But again, what the market's in is principle and plan. but what the market doesn't see necessarily is practical application. How doable is all this? So can you talk about that, in the briefest terms so we can get on to the questions?
So I'll start off on that. One thing to add is that all because Volkswagen are making batteries, it doesn't change demand. Demand is still the consumer. So if Volkswagen make their own batteries or someone else makes them for them, it's still the same. But the issue is going to be that these raw material supply chains are already tight. So a lot of the production going out 5 and even up to 10 years has been locked up into long-term contracts. Now, VW didn't mention any raw material supply. There was nothing in there about that. But it's going to get increasingly challenging between the companies that have already signed contracts on the basis that they maybe will be supplying Volkswagen or others. It's adding another big, powerful player into that raw material market, which otherwise perhaps wouldn't have been quite as aggressive. This vertical integration suggests that they are going to need to secure their own raw materials at the mine level rather than through suppliers. So, it's just another piece of the pie to an underfunded upstream with a relatively well-funded downstream. The money in this industry has gone backwards up the supply chain. So we've seen investment in EV plants, battery plants. But if you even look at Cathode, which is just one step, or Anode, one step above the batteries in Europe that Volkswagen are planning to make, you've got single-digit percent capacity which will be needed for the region. Like 5% or 2%, depending on the time frame you're looking at. So there's very little commitment upstream, and then the situation is pretty dire at the raw material end as well. Obviously, you can't choose where your raw material mines are, but they're very well sold. If you look at the demand versus what we think realistically can come online. And then the other factor which makes it more complicated is, as Simon said, you can basically build a battery plant in 2.5 years. It takes longer to ramp up to capacity. You can build a cathode plant in 2.5 years. A mine, best case scenario, would be 5 to 7, can be up to 20. So it's just more complexity to a part of the supply chain which hasn't been funded properly.
And that's
so
really
maybe in addition to know your supply chain, maybe you should own your supply chain. So it's going to get interesting, isn't it?
That's a really good point, right? A point that Roger just made and the one Caspar made on those timeframes. I like to frame it as, the mining industry lives on geological timescale compared to the battery industry. So these things are decade-long planning processes. If you're not thinking in terms of 10 years for this whole story, then your planning is off. You're going to have a big problem. If you're thinking in 10-year denominations, probably more like the oil industry does, then it's game on. And actually, long term, you will eliminate, or the vast majority of, let's say, reduce the volatility in raw material prices. You'll have your batteries, and you will waste less money on your investments. But at the moment, people are thinking in 4-year denominations because they're so worried about what the actual demand will be. The reality is, we're coming from such a low base in batteries in the supply chain. It doesn't matter what the demand is, because you're never going to be able to meet that demand, whatever the case you're at, because we're so far behind on the supply chain.
Right. You're ringing alarm bells here, and I know you have for some time. Listen, can I make a request? Anyone watching this who has scheduled their day to finish in 15 minutes, I apologize. I've made a complete cock up of hosting this by way of we're going to spill over by at least 15, 20 minutes, maybe even half an hour, if that's okay. Because I think we should jump into questions, because we've now got over 40 questions. So can we try and really spin through them fast and do our best to answer as many as possible? I mean, they all need to be answered properly, but let's start with Ranulf. So what is the state in the supply chain for nickel manganese cathode materials, and what does it mean for the invested capital in nickel manganese cobalt by current incumbent manufacturers? That was the first question of the day, so that gets asked first. Anyone want to give a quick one to that, please?
A quick one to that would be, there's significant capacity, but it's all pretty much located in China. I don't know the exact figure, but I want to say about 85% of cathode capacity is in China. So, a lot of the European plants who are looking to source local aren't going to be able to do that, for their raw materials, obviously, but their chemicals, processed chemicals and cathode. So there is a reasonable amount of capacity, but it's it's regionally not very diverse. It's mostly
Got it. Steve Promnitz, who I know because when I've hosted some of your shows, he's the fella at Lake Resources. He says, we understand that the 6 VW gigafactories need about 200,000 TPA of LCE. I'm just going to do the abbreviations. But where will they source that, and how will they source that sustainably to tick the box on ESG?
Am I taking that one? Where will they source it? Well, they're going to have to go to the raw material suppliers. I mean, obviously the 2 big producing regions would be spodumene in Australia and Argentina and Chile for brine operations. But there are, projects being developed globally. That's not the only places where lithium exists. So, I mean, where will they go for? They'll have to go and, speak to suppliers that have material left for long-term agreements. I think that's going to become increasingly challenging. Now, obviously, as Simon said, lithium prices have increased about 100% year to date. That's going to help new production be incentivized, and we'll start seeing reinvestment in the supply chain from incumbents and new supply. But, more is needed. We've had 3 years of underinvestment. So, it's that higher price is needed to incentivize that.
And we've had the person, man or woman, who always comes to these events, anonymous attendee, come along again, and they basically asked that question, that point you made earlier, Caspar. The surprise of the high manganese battery content for mainstream volume. There's a bit more in that question than that. I'm not going to read through the whole thing, but why was that a surprise, and what might its impact be? Simon, I think you know a bit about that too, don't you?
Yeah, but Caspar loves the chemistry, so I always let him take the chemistry ones. Go on, Caspar.
So high manganese is something that has been kind of discussed in the industry for a while. It's got some challenges around cycle life, or historically has had some challenges around cycle life and capacity, which doesn't make it that well suited to kind of longer range EVs. Now, early indications are that technology would perhaps be slightly more energy dense than LFP, but probably not as energy dense as high nickel. Now, it depends how much range you want. I think there's some challenges around kind of the early charge phases and formation, which, all of these are being worked on and could potentially be overcome, but it's a bit of a surprise that VW have sounds like they've committed to that, for the bulk of their volume. I would say this is, again, something that they're working towards. It's not something that's going to happen anytime soon. And, that any new battery technology or cathode type, or however you want to view it, will take a long time to commercialize into the industry.
Yeah, I agree. And this is the same issue we had with Tesla's battery day. Is there's a lot of announcements that are in different sort of time frames, and I put the high manganese one at the end, much longer time frame for the, let's say, as a prevailing trend, because there's no one straight answer, but a prevailing trend for VW. That high manganese is well into the future, much like Tesla's 100% silicon, which will probably never happen, is also well into the future.
Okay, I'm going to combine a couple of questions here, Kaushik and an anonymous again. Battery factories and how they all kind of come together. So how do you think LG, Panasonic and all the others are going to reconcile where they are with now what Tesla have been doing and Volkswagen are doing, with these car companies taking control of and responsibility for the battery supply chain? Where does that leave some of the incumbent players? That's quite an intriguing thought, actually, isn't it?
Yeah, I think there are some questions. Obviously, within Europe, you've got LG. I don't know if they've got the biggest plant in Europe. It's probably CATL, but coming online. Northvolt will still be working with VW. I think they've got the expertise, but auto companies now trying to get into it. They still have a place. Simon, Caspar, do you have anything?
Yeah, I think it all comes down to who's taking control of this, and as the big plants at the moment in Europe are LG Chem's plant in Poland, and you've got Samsung SDI's plant in Hungary. CATL are building a plant, so it'll be really interesting to see, the Chinese champion and how they play the European strategy. But Europe is it's a brand new 21st century free for all for whoever's going to control this battery supply. VW stood up yesterday, or a day and a half ago, and said, we're going to control the supply of batteries. But do you think LG Chem would like that? Do you think CATL would like that? Or even Samsung? Isn't going to happen. And so, Northvolt's a new battery company. They haven't made started outputting commercial lithium-ion batteries. They're a much needed pioneer, but it's a hard game to play as well. So, it's a free for all, and VW have stood up and said, we want to control the supply of batteries. We want to control the chemistries. Come along if you're up for it. I don't know if that's fair, Caspar.
Yeah, I think that's kind of an important point as well to kind of add. I think you've both covered it well, but VW haven't said we're doing this alone. They have said with partners. So it suggests that the door is open for someone that wants to work with them under a VW controlled partnership, rather than VW being a kind of key customer to the cell company, which controls the flow of batteries and the technology pathways, etc. So, that I think there is an important differentiation there. It's not just VW going it alone, but they're obviously trying to, the goal is to take control of that cell supply.
It's a pity we haven't got Adam on this from Rawles, because Alan Burns asks a great question. VW will require a lot of capital to build gigafactories as they retool and retool their factories for EVs. How will they raise this capital? What happens if EV demand is lower than expected and then VW is financially stretched? I mean, that's a big question, because this is like the whole industry globally. How do you have this managed transition? Who is in charge of the switch? Is it legislation led, or is it something more organic in terms of, the rate of change? They need money that they make from combustion engine manufacture at the moment to fund this EV ambition. So I know it's a more strategic question than battery minerals and supply and all of that stuff, but I think it is a really big question. So thanks for asking that, Alan. Who wants to have a go at answering it? I've got an opinion, but I'm just asking the questions. I'm not answering.
You're on mute, Simon.
I've got a guest on the phone, Roger, to answer that question. Adam from Rawles.
Well done. Did you hear the question, Adam?
So, Roger, just wrap up that question in a sentence for Adam.
Okay, how are the manufacturers going to pay for all of this new EV stuff? And who is in charge of the adoption rate of electric vehicles? Is it legislation? Is it something organic? Or, how does the business model of all this work? Basically, that's what Alan Burns and many other people are asking and thinking.
Yeah.
On the adoption rate, I mean, it's a good question, because ultimately it starts with legislation. And then it's a question of how do OEMs meet the legislation. So there's, they would be fairly agnostic about technology to start with, but what they're left with ultimately is EV at the moment, in terms of meeting those CO2 targets, meeting nitrous oxide targets by the Euro standards, and ultimately phasing out into the.
So that only gave us half of it. Oh, there we go. He's back. Finish that second half, Adam.
I think come back now. The ultimate responsibility is with both. It's both with governments and with OEMs. But ultimately, OEMs will have to deliver the vehicles. So yeah, frankly, it's down to them.
Excellent.
There you are. There you are, Volkswagen. It's down to you and everyone else. I like the way you did that, Simon. That was very innovative. So okay, here we go. China installed 112,000 public EV charging points in December 2020 alone. That's more than the entire US public charging network, blah, blah, blah. This is again from Anonymous. How many kilograms of copper are in an individual charging point, and the future demand for copper being underestimated? Very good point. Let's not just think about batteries. We've also got to think about the charging infrastructure, which of course Volkswagen talked about in the association with BP now, which they've formally announced. And, my friend Giovanni Palazzo was there from Electrify America, done an amazing job. We know where the 2 billion investment came from. Of course we do, but they've got on with it. But this is a good point. What about the minerals and raw materials that need to go into the charging infrastructure as well as the battery stock? Do you have any metrics on that?
No, but it's a double whammy for copper, quite simply. And the copper is used in a lithium-ion battery, and it's used a lot in the copper wires, right? And so that's why people love copper, and copper is going to be In addition to all the industrial demand that copper's going through, it's plugged straight into this electric revolution, this electrification trend, and that's why people love it.
To add to that, well, just first of all, yeah, copper is the other big winner from, of the materials that are going to be going into this kind of the whole ecosystem, not just the EVs. But we don't cover copper at Benchmark, but ultimately it's the numbers are staggering. So it's going to be another big winner. But I think this kind of ties back into the last question as well, when you're saying about how are VW going to pay for this. They're obviously kind of spreading, they're growing the business into not just a vehicle business, but kind of an energy/battery ecosystem business. So never before did you have a VW petrol station, right? You never had a filling station that was VW. But now, in a sense, getting into charging, and investing in charging, that's kind of starting to change. So they're going to be getting, other revenue streams from there'll be, services and revenue streams that will be coming around electric vehicles, which don't just relate directly to the sale of the vehicle, which I think will be an important factor. It's going to be capital intensive, obviously, but ultimately in the longer term, that's going to be an important factor to growing the revenue stream.
Okay. Right. Well, look, we're coming up to the hour. We are going to go over by 20-30 minutes. I'm sorry if anyone scheduled their time and can't stay with us, but if you've only come along for the hour and you need to go, thank you for joining us. I hope you've enjoyed it. I think particularly this Q&A side is very, very useful, because these are all the awkward questions. I asked the easy ones earlier, I think. So keep them coming. We'll keep doing as best as we can. I'm trying to not duplicate questions, so forgive me if I skip over one. Don't take it personally. So here's a good question from Bo, who's saying, could you comment on the work done by the EU Battery Alliance, if you know about it? The latest development is focusing on skills and raw material supply. I must be really honest, I should know a bit about that. I try to know a little bit about a lot, but I don't know anything. Do you guys?
I know. Yeah. Oh, sorry, go on, Simon.
I mean, from let's say a really a government standpoint, the EU Battery Alliance is crucial. It's been one of the crucial components of the EU, firstly, understanding what this whole supply chain is about, and then bringing in the actors to take action to build components of that supply chain. And, I think this is something that the US needs to replicate, is you have a, representative body like the EU Battery Alliance that brings in the industry. It brings in a consistent message, let's say, accurate enough, consistent message of this is the state of play in the supply chain. And then you bring in the money, and you bring in the guys that want to invest. Okay. So I think, and then you bring in the government. So you create the policy and the legislation around this accurate story. And these are three pillars: the industry, the banks, the money, and the government are the three pillars to making this lithium ion economy work. And that's why Europe is so far ahead of the US. Let's say North America, because Canada has a great opportunity to supply and build the new mines for the US as well. But so far ahead, and a big part of that is down to this Battery Alliance. So I congratulate the work they've done.
I just looked at the link. Bo kindly put a link up, which we'll share obviously later. I did know about it, I just couldn't remember what it was called. But you're quite right. That's the key thing, is putting together these core elements of things and making it, it's got to be joined up thinking and action, isn't it? So yeah, bravo for that, Bo. Thank you. Our friend Howard Klein. In 2019, VW announced 10-year memorandum of understanding with Ganfeng Lithium, talking about security of supply. Now, EU Raw Material Alliance saying 80% supply to come from locally. We're looking at, deglobalizing. The pandemic's shown us that we need to reduce our supply chains and all of that stuff. There was no comment from VW on Monday about this. So does this mean they will carry on buying lithium largely from China, or how is the geography of all of this going to come together, given we're trying to reconcile some really, potentially sort of conflicting challenges, localize more, deglobalize. You've got issues with geopolitics going on. We know about that without getting into that can of worms. How does this all reconcile? And what about Howard's point? Anyone?
Yeah. For me, the most telling thing, and it is, it ties into Howard's point and a number of other things, is how the word lithium wasn't really mentioned in a big way in this whole day, in this whole message. Now, what the volume was mentioned, right, Rob, on one of the slides? Is that correct?
No, I think we sort of took their numbers and used our numbers. So
Extrapolated.
Indeed, thank you. That's the word I was looking for. So roughly our numbers, 270 gigawatt hours would equate to 200,000 tons of lithium. Put in that
240.
240. Sorry, 240. That's more than supply in 2016. It's more than around 60 to 70% of lithium supply, global lithium supply in 2020. And it's still, looking forward at our forecast, even by the end of the decade, it's still a sizable proportion. So there's the context for you, Simon.
Yeah, and for me, lithium wasn't mentioned much at all. And it wasn't even put on the slide, interestingly, for battery recycling, which I think is fair, because actually I think lithium is one of the hardest things to recycle out of a battery. Nickel and cobalt, let's say the metals, those are actually much easier to recycle out. So yeah, I think the absence of a lithium comment is telling. And also I think Tesla are making lithium hydroxide in Austin. So first automotive maker ever to get into lithium production. And for me, I think it shows that, the big autos should be worried about lithium. They've spoken about nickel, but they should be worried about lithium right now.
Okay, thank you for that. Oh man, we've got so many questions. Right, here's one that we hadn't heard from Joe Williams. Are these large format cells likely to be more susceptible to swelling issues, graphite and cathode implications? Bang, that's his question. What's the answer? Come on.
No, essentially no more susceptible than anything else. In fact, prismatic will potentially be less susceptible, but we need to know more about exactly what the format means. But yeah, no, in a word.
Okay, thank you. Quick question, great answer. Ben Crew says this, and I'm with you, Ben, I'm with you. How does the group see the announcement shaping decisions in the UK auto industry and UK-based OEMs in the coming years? Clearly there wasn't a gigafactory announcement for the UK and those 6 for Europe. There was obviously a connection in regard to, I think, the BP announcement from the fella at BP was based in London. But yeah, Ben's question: how do you feel? Has it changed anything?
I'm not too sure. Simon, you'd looked at some stuff on the UK recently.
Yeah, I mean, from my perspective, the UK is, well, it's well behind. It's not just behind. It's just starting. I'm not talking about like the academia in the UK. We have some of the world's best battery scientists and best researchers in the world. We just don't have the companies commercializing it. Like, it's the UK should be the pyramid we showed at the start, that Will showed, that tier 1 battery manufacturers. We should be attracting or talking to on a government level to 3 of those 6, and saying 75% of our battery capacity has to come from these tier 1 makers. They build the base of then, our electrification, our EV or energy storage revolution. And we haven't got any of those down the pipeline. There's some stories and headlines about Tesla, because people love writing headlines about Tesla. Headlines and rumors aren't actual plans for gigafactories, and the government and policymakers in the UK need to actually get serious and start understanding this. Just learning it for 6 months isn't understanding it. Actually having people in place like Darren Quayle, who's been saying this message for a long time, is crucial. And the government, regardless of what they've said, regardless of the £500 million they've said we're going to put to gigafactories and making these nice memes on Twitter, they are so far behind that I fear for the future of our auto industry. It's that simple.
Well, you're not the only one, because as you know, and you've had him on your show, Dr. Andy Palmer has talked about this for a long time, and he's got, he knows this stuff. He was there with various other people putting together the first gigafactory in possibly the world, well, certainly in Europe, with the Nissan plant up in Sunderland. And then we've got Antipower, we've got British Volt, we've got people on the edge of this, and you see the Battery Innovation or Industrialization Center there to encourage this stuff. But yeah, you're right. It just doesn't seem to get pushed far enough. And we seem to be spending money on the wrong thing. I mean, I don't want to go off on a tangent, but, it's 50, 60, 100 billion for a high-speed rail network. Could have a quarter of that could have gone into having a true battery revolution here by putting that money into some of these things. But sorry, that's me. I mustn't go off on one.
That's a good point. I mean, the high-speed rail, to be fair, I don't mind the high-speed rail thing. I mean, the management, of course, is very, very clear.
You would if it went by your house.
No, for sure. But I don't mind us investing in the future. That's what high-speed rail is. So
yes.
The principle of it, we should be doing something like that. I mean, the management, whatever. Batteries are investing in the future. Yes, but so far behind. And hydrogen's one, that's a good thing we're investing in, but hydrogen also gets a hell of a lot of airtime in government, more than batteries. And actually batteries is what can be powering 80-90% of all of our transportation. And so there's got to be an understanding of this. And actually people have to be trying to see the future as China does. And they're not. And that's going to put you so far behind in the next 20 years. It's going to be incredible.
Well, Mr. Moores and co and your chums there, get yourselves into Downing Street or the cab, in the cabinet office or something, and have a little conversation about this, because something's broken somewhere. There's some line of communication that's not working here. Because if I can understand it, what you've described and other people have been saying for a while, then it can't be that complicated. So yeah, let's get on with it. Can I ask a question? Well, I'll put one more question from the audience. Can you guys start choosing questions? Because I might pick, we can't do them all now. We've got nearly 60 and we're going to run for a bit longer, but obviously, let me just ask one more from it, then please start choosing them yourself. So Michelle says, interesting that VW is choosing LFP and high manganese, nickel, cobalt, manganese chemistries. Presumably that's aimed at cost competitiveness. Any comment in this trend to high manganese cathodes? I think you mentioned a bit of it earlier, Caspar. Any additional thought to that question from Michelle?
I mean, it's, as I kind of said earlier, it should be cost competitive. Yeah, it's to do with cost ultimately, and also kind of fear over, because the other thing is everyone's been so focused on cobalt, they forgot that moving to high nickel means you need a huge amount of nickel that potentially might not be there in the future. Now, there was an announcement a couple of weeks ago by Tsingshan about using a product called nickel matte that comes from nickel pig iron, which does change, theoretically, could help with swing supply when class 1 gets tight, but that's some time away. But ultimately, I think automakers aren't just scared about cobalt anymore, it's also nickel. So moving to high manganese would alleviate some of those concerns. But as I said, as a technology, there are still question marks over how well it will perform versus what's available today, which is essentially LFP and NCM for those automakers. So at the moment, we're not really seeing any other firm commitments. Technology timelines are basically focused on moving to high nickel 811, 9half, etc., with some silicon in the anode. But we'll see what happens. As I think we mentioned, I think some of the solid state and the high manganese is an eventual goal, but it's not something that's going to be actioned overnight.
Simon, do you fancy a question in there?
Yeah, Rob's gonna pick them out and read them out.
Yeah,
Great.
This is just an interesting one. It'll be interesting to give our thoughts. Apple is sitting on a pile of cash. Any update on what they might do? Are they going to get involved? Simon, I know we've discussed this before. Yeah,
Apple getting into the self-driving zone has been there for a long time. The EV battery zone was a thing. Project Titan back in 2015, 2016, they put that on ice. And they're revisiting it now. And Apple getting into the battery supply chain is really interesting, right? And there's no more that we know than that, of course. But the key thing here is, if Apple, much like VW, right? So if Apple get into an industry, well, they want the supply chain. They want to control the supply chain. and who makes most of the Apple iPhones and gathers those components for them. It's Foxconn. And then Foxconn, interestingly, are a small shareholder of CATL, the Chinese biggest battery producer. And Foxconn also have been looking into batteries for years, dabbling with them, producing that. So it's all part of a similar ecosystem. And the ecosystem is batteries, electrochemistry, mining and chemicals in a cell, meets technology, software, and creates lots of lovely, beautiful stuff. And that is the basis of the lithium-ion economy we're talking about.
Thank you.
It's getting fascinating, isn't it? Wow. Go on, Rob.
Just looking at another one, I like these questions. Do you see Tesla responding robustly to Volkswagen's announcement, or just letting it happen, Caspar?
I mean, Tesla have got their technology roadmap out there, or their kind of business roadmap, shall we say, out there. I mean, I don't think there's anything really to respond to from there. Maybe there could be some bits and pieces that they'd kind of, comment on. But I think ultimately, the vertical integration business model is here to stay. I don't see that changing. VW obviously, I think he even mentioned in the presentation, we will catch up to Tesla and overtake them. So they're obviously seeing them as their main competitor. So should make for some interesting viewing over the next 10 years.
Yeah. And also Tesla are way ahead of VW on this in terms of, let's say, not so in terms of the understanding, because there are a lot of really good people at both companies that get this scenario. It's the exec level, right? It's the understanding it at the top level, and then when do you pull the trigger to invest in certain parts of the supply chain, and that's the strategy for the companies. But Tesla is a good 5 years ahead of VW, both in battery capacity, not just what they're building, but obviously the gigafactory, which is the crucial thing, and also look at what they're doing in Austin. They're building cathode, they're building nickel sulfate input eventually, they're building a lithium hydroxide input. So Tesla, VW have just announced, we want to make batteries, which is the right strategy. Tesla are already no, we want to make the chemicals that go into it as well, which is a massive leap. And again, the right strategy, it's controlling that midstream of the supply chain. VW will eventually follow that strategy, I think, because they'll realize just building battery plants isn't going to get you supply chain dominance. But that's where we stand at the moment.
Can I just say something that also came out yesterday when they were talking a lot about charging infrastructure and the dynamics of the shift and the makeup of who's going to buy electric vehicles. The intriguing thing for me is we will come to a tipping point where the range is more deliverable in the infrastructure than off the battery. So that's an interesting point. I think Marcus Duesman said it, and I think even Elon said it. The quest for ever bigger batteries to go ever further just doesn't make sense and is unsustainable. So there is going to become, if we're not already there in various markets, an inflection point where what's more important is the charging infrastructure, not the battery on board, relative to the duty cycle and all those other things. And I think that's an interesting, potentially, equation that we could look at a bit more. And I'm sure, don't get him on the phone again. It's great to see Adam, but I'm sure Adam would have a sense of this. I think you're going to be talking about charging infrastructure at some time, end of the month. But yeah, it's not all about 60 kilowatt batteries, 60 kilowatt hour batteries, 70 kilowatt hour, 90 kilowatt hour batteries. It can't be, that is just going to be, it's just not deliverable, I don't think, when you scale it up. But what else we got, Rob? I know we haven't got time to do all the questions, but so I really would like you guys who know it far better than me to pick ones that you feel are most pertinent.
Sure. Which cell manufacturers, except Northvolt, do you see as main candidates to cooperate or have a JV with Volkswagen in relation to their 4 new mega factories?
Yeah. This is why batteries are becoming extremely geopolitical. The gigafactories that they're made in are what I've described as geopolitical hot potatoes. They are signs of the industry's ambition, automotive industry, battery industry, chemistry industry, or chemical industry, and they're signs of government ambition. How many EVs do we want to build? How fast do we want to go? To answer your question, VW and the European Union will want to have, like they already have, tier one manufacturers building in Europe. They've got LG Chem, they've got Samsung SDI, they've got CATL, Total and Saft, the French specialist battery producer, are building gigafactories in France, maybe one in Germany. So they've got quality already, and they've got tier one. Of course, Northvolt is the new entrant into this that we think will be a tier one producer quite quickly as well. So you need more. I can see CATL coming into Europe in a big way, in a big plant. At the moment, they're dabbling with that plant in Germany, but I can see them doing something significant with VW. It would make sense, but of course, what will the Korean boys want to do? What will SK Innovation want to do? They're yet to plan significantly in Europe, and they've got legal problems with LG Chem in the US at present. So Europe is going to be a focus for SK Innovation's future investment, I would imagine, regardless of the outcome of that case. So it's a whole melting pot of Asia meets Western auto, European auto meets government meets. Let's see what happens. It's all on the table.
Very interesting. Alex quickly says this, what will happen potentially and economically in lithium-rich countries like Argentina and Chile, and obviously Bolivia is another one of those, and you could put Australia in it too. And of course, the DRC isn't just about cobalt, it's about many other things as well. How might the world evolve, do you think, in that way, given the disaster that we've seen in the regions that are the oil-rich regions of the world? Are we going to transfer conflict at the same time as we transfer into a 21st century, electric-propelled world? What are the dangers for those countries, do you think?
It's a big question. I don't think we've got time to answer all of that.
Okay, no. But Alex, great question, my friend.
Yeah, it is a good question, but it's a huge topic. I mean, hopefully not would be the short answer. Hopefully there's no conflict as a result of essentially changing what has been the oil supply pipeline and control of oil to now control of these battery minerals. Now, it is going to shake things up. There is going to be probably some concern over the supply materials, but specifically with lithium, it's not actually that rare. I mean, there's lots of deposits all over the world, so it's not like it's only located in a handful of countries. That's not the same for all battery minerals, but it's a tough one to answer quickly. But as we've said, Simon's already said on this session, is that it's already very geopolitical, and it's probably only going to get more political as time goes on, because it is so crucial to individual nations' economies, regional economies, and essentially, ultimately the climate change problem as well.
As Jeffrey points out here, electricity is the new petrol, right? And the car companies want a big part of it. Yep, you bang on. They made a mistake last time round by basically seeding the fuel, the recurring revenue opportunity of fuel for vehicles, and they ain't going to do it again this time. And they've got to replace the lost recurring revenue of friction parts. So, whether it's data or whether it's energy, you can kind of see it. So you're spot on there, Jeffrey.
Just a quick one on that, Roger. Just for the purists on there, we know that lithium isn't a source of energy, right? It's an energy storage element, but it is as geopolitical as oil. I mean, for me, it's oil first still for a while. But because lithium's at such a low base and it's so important, lithium is number two. And it's important to know that even though it isn't a like for like, you still need to get your energy from somewhere. It is as geopolitically important and representative of this new mega trend, which is the energy storage revolution.
Look, we're not going to be able to answer the rest of the questions, which is a tragic failure on my part. I don't think I've ever done this on any one of your shows, but we've never had so many questions in. But let's go back to the focus on giving feedback on the Volkswagen Power Day. Would you each like to give a bit more additional flavor, maybe repeat to some extent what you've already said? They covered an awful lot. There were batteries, there was chemistry, there was recycling, there was charging infrastructure, a bundle of things. Let's just go around the room, and we'll finish with you, Simon, if we can. I'll start with you, Caspar. How different, if at all, is the landscape we're looking at now today than it was Monday morning before we saw the Volkswagen show? What's changed?
It's potentially the shift where we start to see automakers, move into other parts of the battery supply chain, shift through vertical integration. Now, before really, outside of China, it was only really Tesla that was doing this. So, if this is obviously it's not going to be all automakers, but for major automakers, this is the business model. It significantly changes some elements of the power in the supply chain. It significantly changes where raw materials will be purchased and how they will be used by automakers. But I think overall, it's confirmation of something we've suspected for a long time, which is that the automakers are going to have to make these investments in the value chain for them to scale at the right speed that they need. And they're also going to want to do it in terms of security of their business model and supply of, the critical parts of the EV, essentially.
Thank you. Robert?
I just wanted to put some numbers out there for context. In fact, I've just disappeared from my screen. Bad timing. I was looking at, so in 2015, I think lithium ion cell production was around 75 gigawatt hours. And then 2020, I think consumption was around 216. And production's around 275, which is about the amount of capacity, maybe more, that Volkswagen is going to have to add alone in the next decade, less than a decade now. So it's just good to see how far things have come in terms of battery production over the past 5 years, 10 years. Looking forward, it ramps up even further now.
Absolutely. So Simon, it's a Rubik's Cube, all these things that we've talked about. What's your sense then of how quickly can Herr Diess fix the Rubik's Cube and get all the color sides to match? You're on mute.
Hold the Rubik's Cube up again. This isn't planned. This is me free. This analogy could absolutely fall on its face, but I'd say the green is lithium ion battery supply. The orange is chemical supply, cathodes, anodes, lithium hydroxide. And the yellow is raw material supply, digging out the ground. The problem is you've got to get all of those, you've got to get this Rubik's Cube aligned, which, Roger, I'm probably going to ask you to do now in the next 30 seconds.
Yeah, no problems.
Yeah, this Rubik's Cube has got to be aligned very quickly. And it's going to be
doing my best.
Because of the timeframes, it's going to be really problematic, right? The raw material supply and the chemical supply, as Robert Freeland said to us, it's getting the contents of a Hoover Dam through a garden hose pipe. That's the analogy, and it's superb, right? EV, like the build out of the supply chain and getting the raw materials out of the ground, will be the slowing factor for electric vehicle adoption. There's no shortage of it. We're going to get there in the end, but it's going to be the next decade that actually this pain is going to be suffered. Post 2030 or late 2020s onwards, the investment will be there, and then we're going to have this new. I liken it to the movie The Day After Tomorrow. So I don't know if anyone's seen this movie, but it's about it's a climate change movie, right? And this perfect storm happens, and a big wave hits New York, and eventually, after this perfect storm, everyone moves to like the equator, Mexico and stuff, and sets up your new life. We're going through this perfect storm of pain the next 10 years. Once the storm is settled, we're going to have this base, this blueprint to this lithium ion battery economy, this energy storage revolution, where mine level, chemical level, and battery cell level line up as perfectly as possible to feed the EV demand, which again is very unpredictable if you have to electrify everything. But it's going to take 10 years. And so what VW did was saying, we aren't a car company anymore. This is a 20th century thing. We are a lithium ion economy company, which involves lots of different assets: car production, battery production, energy movement, energy, selling and buying energy, all of this stuff. We're not a car company. We are a lithium ion economy company, and we want to be valued as such. And I think that's also a reason why they saw a significant share price bump as investors begin to get what we're about to go through.
Very well put. I think all they need to do now, this is my recommendation, Edis, just take the K out and put a T in. It's a rebrand exercise. It will be quite cheap because you can just change one letter. It fits. So Volkswagen, that's who you are now. That's how it is. And funnily enough, when the bad business happened with diesel, and let's not sweep that aside, it was in all of what it was, it should never have happened. But it was the pursuit of trying to get the emissions down, ironically, and all of that journey. But out of that, this is like Phoenix rising from the ashes. It's like the prodigal son. It's all of those things. Sometimes the worst thing has to happen for the best thing to occur. And as a kind of, if I can, as a maybe a clumsy association, the pandemic is the worst of things in anyone living's life today. It's disrupted whole economies. It's done irreparable damage to many things, but more importantly, people have died and it's changed everybody's life. However, out of that, the reconciliation of, well, what can we do better? How do we build back green? What can we improve? What do we reflect on? All of that is absolutely, definitely coming out of this experience of pandemic. So it's another illustration of how sometimes a bad thing has to happen, sadly, for good things to come as a consequence. So that's my kind of interpretation, if I might put it like that. Look, this is dreadful. We've had so many questions and have failed miserably to answer them all, but we've done our best. I think, gentlemen, I'd like to thank you for coming on and sharing your thoughts on this. I know there's a lot more for your customers who can sign up as we explained as Will explained at the beginning. So there's obviously a lot more to this. This is just a skim of the surface, but hopefully it's been helpful, interesting, and useful. So on that note, unless you'd like to chip in with anything else, I think we're done for the morning. I think people have got work to do, places to go. Well, maybe not those, but work to do. So Simon, go on. It's your company. You please finish off.
Yeah, no, thanks, Roger. Just briefly, we have a free newsletter. Go on our website, benchmarkminerals.com. It's a little red button at the top. Sign up. That's all the free stuff. Obviously, the really good stuff, the data, the analysis. We have a whole wide range of subscriptions from mine level through to battery cell, and we do analysis. We've got everything you need. Just contact us on the email that you registered with this, and we are more than happy to be your provider of information for this energy storage revolution. And just a final thanks to Roger. Connect with Roger Atkins if you don't know him. He knows everyone in the supply chain. I call him the great connector, the voice of electrification. We need to think of something even more grandiose than that, but on a genuine basis, he is. So Roger, you've been a great asset to us, and you are very knowledgeable. He says he isn't, but he is. So he knows his stuff as well. So thank you to Roger. And thank you to all for tuning in. So cheers.
Yeah, thank you for all the questions. Thanks a lot. So we'll see you soon. Goodbye, everybody.